going to look at the two leaving cert methods of factorising that you need to practice. So you have 4 junior cert methods, extremely important, those 4 methods. And these 2 leaving cert ones, there's, skills to be done just like the junior cert ones. But I guess in comparison to the junior cert ones, it's more rare that you would use these. So these are skills that I would practice now and make sure that I find doing these questions and being able to factorise them quite easy and straightforward. And then it's not something that I need to practice all the time and make sure that it's, there for me all the time. But it would be something then that I would practice and look at the night before an exam, just in case on a rare occasion this type of factorising did come up. So it's very like, so I'm going to compare it to the difference of 2 squares, where for the difference 2 squares, you have to just learn that you put down your 2 brackets. It's the first minus the second and the first plus the second. How would you know if you were right or wrong? You could multiply it out. And you would see, yeah, those 2 factors do multiply out. Sorry, that's a minus. To give you x squared minus y squared. So if I put down this question, x cubed minus y cubed, and asked you to write down the 2 factors that multiply to give you this, I think you would be there a while. This would be probably easier to come up with, even though it's not, you'd still probably be there a while trying to find the factors. So I'm going to just write down the 2 factors. It's usually, so it's actually not unlike this. So your first bracket is kind of similar and your second one is a little bit longer. So it's the first one. So this is the difference of 2 cubes. So it's the first minus the second. It's the first squared plus the first times the second plus the second squared. Now, are they the factors that multiply out to give you that? I don't know, would you actually believe me? Because they look quite large kind of things, that 2 factors that multiply to give me something so small. So perhaps that is something you would like to multiply out and check in case, I've made a mistake on something, or that's not actually the factors of it and I'm lying to you. So we call these the difference 2 cubes. So when you have something cubed on the left, a minus, and something cubed on the right, you can put down your 2 brackets. The second one is going to be a little bit longer, and it's the first thing that is to be cubed minus the second thing that is to be cubed there. So I'm just going to call them the first and the second. And then it's the first squared plus the first times the second plus the second squared. So that's our first of the leaving cert type ones. The second one, is similar enough. It's actually the sum of 2 cubes. So to sum things up means to add them up. The difference means what's the difference between those 2 things? To subtract them. So again, once you have something here to be cubed and something here to be cubed, then you put down it's the first plus the second times the first squared minus the first times the second plus the second squared. Again, looks quite large. Does that really multiply out to give you this something so small up here? You have to just check that out and see. So there are your 2 methods there, 2 pretty easy, straightforward questions. I guess what I notice is, so this is just for me to try and remember things. What I notice is, when you look at this, there's only 1 minus. And again here, when you look at this one, there's only 1 minus. So if I'm trying to figure out, they actually are quite similar. It's just about where do the signs go in. So what I notice is there's only ever one minus. This bracket, the first bracket, always seems to match this sign. And then if the minus hasn't been used, well, it has here, so I'm left with just pluses. It hasn't here because these have to match, so it comes in straight away afterwards. So as fast as you can, you get the minus in, and if it isn't allowed into this bracket because these have to match, then you put it down straight away, and the rest have to be pluses. So this one is the first minus the second, the first squared, plus the first times the second, plus the second squared. And this is the first plus the second times the first squared minus the first times the second plus the second squared. As I said, you might not believe me that they're the factors, so you might want to multiply them out. Just like with the difference two squares, I could write down a question where it's 9x squared minus y squared, let's say. Everything has to be written as a square. Okay, now if you want to, you could clean this up and just write it like that. But whichever way you want to do it, it's whatever's on the left that's to be squared, minus whatever's on the right that's to be squared, and whatever's on the left plus whatever's on the right. So it's the first minus the second, the first plus the second. It'll be the same down here if we went for, something like that. So let's do the difference of, let's do the difference of two cubes. So everything here, if it is the difference two cubes, and you'll still, I'm telling you it's the difference two cubes at the minute, but you would have to run through your list of, is it common factor, is it grouping, etc. And we'd eventually get to, right, it looks like a difference between two cubes, but I need to rewrite this as something cubed. So 27 can be rewritten as 3 cubed. And again, you could rewrite this as 3x to be cubed if you want, whatever. And so now that I know it definitely is the difference two cubes, I put down my two brackets. Second one's a bit longer. It's whatever's on the left, or the first is what I call it. This sign has to match minus the second. It's the first squared plus the first times the second plus the second squared. Now I need to clean this up because I can. I'm capable of doing that. So we're going to just clean it up a little bit. Obviously, I'm still, they're asking me to factorize, so I'm still going to leave it. I'm not going to multiply it all back out again. I just get back to the start. So I'm just cleaning this up. What is 3x to be squared? It's 9x squared. What's 3x times y? It's a 3xy plus a y squared. If you multiplied this out, would you get back to here? Well, I'm saying yes, you would, but you might want to check that out. So there's another example with the difference of two cubes that isn't as maybe straightforward as the one that I did up here.